Hello everyone. In this video on integral calculus, we would be discussing about the concepts and the processes involving indefinite integrals. Disclaimer though, before watching this video, you must have understood fully first differential calculus. Okay, so going back to the task at hand. So in indefinite integrals, for starters, what we would be doing here is basically the inverse process of our differentiation, or what we have been doing in differential calculus. So what does that mean? So suppose that we would be having a certain function f of x, so f of x. So if we are to get the derivative of this function right here, we would be arriving at an answer of f primes of x, and let's say f's of x. So in integral calculus, what we would be doing is, once again, the inverse process of it. So if you would be getting the integral of this, you would be arriving at an answer very similar to this one right here. So let's have an example here. So suppose that we would be getting the derivative of, let's say, sine x plus 3. So let's say that we are to get the derivative of this. So d over this of x. So this is to be equal to cosine of x plus 0, since the derivative of a constant is equal to 0. And there. So if you would be cross multiplying this one right here, so the derivative of sine x plus 3 is equal to cosine x dx. So there. So for pretend that we would be getting the integral of this one right here, you should arrive at an answer very similar to this one right here. So take note, it would be similar and not exactly this one right here. So I would be explaining to you why later. Okay, so in integral calculus, it is often called as antiderivative, since once again, considering these functions right here, or the first derivative of this function, you must arrive at an answer very similar to the original equation. So with that being said, in solving for indefinite integrals, the first thing that you should ask yourself is that what values did we differentiate for us to arrive to the function that we are integrating? So there, and in integration, this is to be its equation. So we would be having this symbol right here. So this is to be your integral symbol, followed by your f's of x, then dx. And since this is to be an indefinite integral, we wouldn't be having our limits. But suppose that we would be solving for a definite integral. So that is to be the integral of f's of x dx with our limits. So let's say this is to be our limit x and this is to be our limit y. So once that you have these terminals right here, or these limits right here, this is already what you would be calling a definite integral. So definite. And this one right here is to be indefinite. So there it would be simple as that. Okay, so I would be erasing this one right here, and let's have another basic example. Okay, so suppose that we would be having this certain function right here. So let's say 7x raised to 6. If we are to get the integral of this one right here, so by the way, d is of x. So if we are to get the integral of this, we would be using this symbol right here, which is the indefinite symbol. So the first thing, once again, that you should be asking yourself is that what function did we differentiate to arrive at this function right here? So this 7x raised to 6 right here is to be your f's of x right here. And what we are solving for is to be this one right here. So to think of it, the values that we have derived for us to get this value right here is basically x raised to 7. Because if you would be getting the differential of this one right here, so let's say that d over dx of this equation right here is equal to 7x raised to n minus 1. So n minus 1 is equal to 6. So as you can see, this one right here is to be this one right here. But there's a catch. This is not the only equation that if you would be getting its differential would give you this value right here. So another possibility of an equation is x raised to 7 plus 1. Or let's say x raised to 7 plus, let's say, 800. So if you would be getting the differential of this or the derivative of these equations right here, you would still be arriving at this equation right here because the the derivative of any constant is equal to 0. So from that, let's have this one right here as an example. So I would just be writing it here. So if we are to get its derivative, so that is to be equal to, so 7x raised to 6, and the derivative of a constant is equal to 0. So there, and as you can see, 7x raised to 6 plus 0 is basically this one right here. Okay, so to simplify our answer, so I would just be erasing these ones right here for us to have a neat work. So listing some of the possible answers. So one possibility is, let's say, x raised to 7 plus 1, or let's say x raised to 7 plus 3, or let's say x raised to 7 plus 900, etc. So we can generalize these answers right here as x raised to 7 plus constant, where your value for your c is to be any number or any constant. Okay, so in the said problem, it is stated there that the integral of 7x raised to 6 dx is equal to x raised to 7 plus c. So what we actually did here was that we have thought of possible equations that if we are to get its derivative would give you this one as a result. So aside from thinking of possible equations to differentiate or to get its derivative to arrive at this answer right here, we can actually use this formula right here, which we would be calling our power formula. So this formula right here, or this method right here, is the most common formula in getting the integral of a certain equation. So there. So for our power formula, the general equation of it is that if we are to get the integral of u raised to n times du, this is to be equal to u raised to n plus 1 over n plus 1 plus c. So this is to be its general formula. So now using this equation right here, let's use it to solve for the integral of 7x raised to 6 dx and check if we are to get this value right here. This equation right here. So the first thing that I would be doing is that I would be separating this coefficient right here and move it to the other side of the integral symbol just for me not to be confused. So this is to be equal to 7 times the integral of x raised to 6 dx. And as you can see here, this is to be the equation that we would be needing, and this is to be u, this is to be n, and this is to be du. So from that, the value for our u is equal to, well, this one right here, which is x. And the value for our n is to be this one right here, or the exponent of u, or x, that is to be 6. Then as for our du, so that is to be this one right here. So that is to be this of x. And we actually have rules to follow here, but I would be indicating that to you in the next video. But for this time, I would just be explaining this one right here if we are to get this equation right here. Okay, so from that, using these equations right here and this general equation right here, we can now solve for its integral. So this is now equal to, so 7 times what would be the answer here? That is to be this one right here. So u raised to n plus 1, and our u once again is equal to x raised to n plus 1, and our n is equal to 6. So 6 plus 1. So divided by n plus 1, and that is to be 6 plus 1. Then we would be adding c. So plus c. Plus c. Okay, so I would just be moving this to the left for us to have space. So this is to be equal to. So simplifying this equation, that would give us an answer of 7 times x raised to 7 divided by 7 plus 7c. But take note, guys, that a constant multiplied by a constant is equal to a constant. So this is to be equal to. So this would just cancel out. And our final answer now is to become x raised to 7 plus c. Since 7c is still a constant. And as you can see here, this value right here is to be exactly this value right here. So they are to be the same.